Hello Cloud Pedagogians, welcome back to the course. Thanks for joining me in this session. In coming up lessons, you will be learning how to create a VPC. First, we'll understand what is VPC and what are the subnets and how to create them. Next, we will see what are the gateways we have in VPC. Next, we will see how we can keep high availability using the VPC. And finally, we'll understand what are the reserved IPs are. So, what is VPC actually? A VPC is nothing but virtual private cloud. A VPC is an isolated network you create in the AWS cloud, similar to a traditional network in a data center. The idea of the VPC is similar to how you think of walls around a data center. In a data center, walls acts as the boundary between the outside world and all of your infrastructure. A VPC in AWS acts the same way. It creates a boundary where your applications and resources are isolated from any outside movement. So nothing comes into the VPC, nothing comes out of the VPC without your explicit permission. So when you create a VPC, you need to choose three main things. The name of your VPC, a region for your VPC to live in. Each VPC spans multiple availability zones within the region you choose. Finally, you define a IP range for your VPC in CIDR notation. This determines the size of your network. Each VPC can have up to 4/16 IP ranges. Using this information, AWS will provision a network and IP addresses for that network. In our student directory application, we will be locating it in the region where the rest of our infrastructure will be, the North Virginia region, and our IP range will say 10.1.0.0/16. Alright, so currently our VPC just looks like a box and we need to build this out with other components. Next, we'll understand what are the subnets. After you create your VPC, you then divide the space in the VPC into smaller segments called subnets. Think of subnets as smaller networks inside your base network or virtual area network, which are VLANs. In a traditional systems, obviously on-premises network. In an on-premises network, the typical use case for subnets is to isolate or optimize network traffic. In AWS, subnets are used for highly availability and providing different connectivity options for your resources. You put your resources such as EC2 instances inside of these subnets. The goal of these subnets is to provide more granular controls over access to your resources. So if I have public resources like our student directory application that we want to be accessed over the internet, I could put those resources inside a subnet with the internet connectivity. If I have more private resources like a database, I could create another subnet and have different controls to keep those resources private. So when you create a subnet, you need to choose again three settings. The VPC you want your subnet to live in this case VPC 10.0.0.0/16. Next, the availability zone you want your subnet to live in this case AZ1. Finally, a CIDR block for your subnet, which must be a subset of the VPC CIDR block. In this case 10.0.0.0/24. So when you launch an EC2 instance, you launch it inside a subnet, which will be located inside the availability zone you choose. Let's see how we can create subnets in our architecture diagram. In this case, we will choose AZA, or in the other words, US East 1A. And then the IP range for your subnet, which must be a subset of the VPC IP range. For this, we will choose the IP range 10.1.1.0/24. We will call this our public subset for public facing resources. Then we will create another subnet for our private resources. We will place it in the same AZ, specify a different non-overlapping IP address, say 10.1.3.0/24 and then name it for our private subnet. Alright, now that we have got two subnets added to our VPC, we need to understand the next component about the gateways. We have two gateways which are internet gateways, virtual private gateways. As we mentioned earlier, when you create a new VPC, all the resources you put in it are isolated and only have access to other resources in that VPC by default. For websites like our student directory application, we want users to access our site over the internet. To enable internet activity, we need a component called an internet gateway. Think of this gateway as similar to a modem. Just as a modem connects your computer to the internet gateway connects your VPC to the internet. Unlike your modem at home, which sometimes goes down or offline, an internet gateway is highly available and scalable. When you create an internet gateway, you then need to attach it to your VPC. If you create an internet gateway and don't attach it, it won't do anything except sit there. So next, what are virtual private gateways? In a scenario, if we had a VPC with all internal private resources that we want to reach only from our on-premises data center. If we only want traffic to flow between AWS and our data center and we don't want allow direct access from the internet, what do? Luckily, there is another gateway designed for this very purpose called a virtual private gateway or VGW. It allows you to create a VPN connection between a private network like an on-premises data center or internal corporate network to your VPC. With the help of a VGW, you could establish an encrypted VPN connection to your private internal AWS resources. Once you create and attach a VGW to a VPC, the gateway acts as anchor on the AWS side of the connection. On the other side of the connection, you will need to connect a customer gateway to the other side of the private network. A customer gateway device is a physical device or software application on your side of the connection. Once you have both gateways, you can then establish an encrypted VPN connection between the two sides. We won't be using a VGW for our application, but it's good to know anyway. Now it's the time to add the internet gateway in our student directory application architecture diagram. As you can see here, we have attached the internet gateway to VPC so that it can communicate to the outside world. How you can achieve highly availability with a VPC? When you create your subnets, keep high availability in mind. In other words, to maintain redundancy and fault tolerance. To do so, you create at least two subnets configured in two different availability zones. As you learned in the earlier sessions, it's important to consider that everything fails all the time. In this case, if one of these AZs fail, you still have your resources in another AZ available as backup. Now, every time you look at an architecture, you should begin to think, how do I make this better? Okay, well, one option is to make this better is the idea of having high availability. What that means is if this AZ goes down for whatever reason, what happens to our resources in that AZ? They go down too. So ideally we would have resources in another easy way to take on the traffic coming to our application. To do this, we would need to duplicate the resources in this AZ into the second AZ. So that means we need to create two additional subnet, each with another AZ, say AZB. Now our application is having high availability. Next, we'll look into reserved IPs. For AWS to configure your VPC appropriately, AWS reserves 5 IP addresses in each subnet. These IP addresses are used for routing, domain name system like DNS, and network management. For example, consider a VPC with the IP range 10.0.0.0/22. The VPC includes 1024 total IP addresses. This is divided into 4 equal sized subnets, each with a /24 IP range with 256 IP addresses. Out of each of those IP ranges, there are only 251 IP addresses that can be used because AWS reserves 5. Since AWS reserves these 5 IP addresses, it can impact how you design your network. A common starting place for those who are new to the cloud is to create a VPC with the IP range of /16 and create subnets with the IP range of /24. This provides a large amount of IP addresses to work with at both the VPC and subnet level. Alright, we have learned some of the components that will be useful in VPC. In the coming session, we will learn few more components in the perspective of routing and security. I'm sure we will see each other again in the next topic. Until then, take care.